one says when representing growth, we're going to use a ratio greater than 1. So I want to show you this one the long way and the short way again, just to emphasize you could do it the long way if you forget how to do this. Compound interest. Emily needs money for college. She plans to invest $1,000 in a bank account that earns 2% interest each year, compounded annually, so once a year. When you guys take personal finance, you'll learn about the compound interest stuff. Find the value of the bank account after 1 year. Don't write this down yet. If she has $1,000 and she gets 2% interest, how many dollars does she make that year? So I got, if I move it 3 decimal places, right? $20. You would think 0.02 times 1,000 would be $20. Does it make sense that that's the value of her bank account, though? The value of her bank account is going to be 1,020. Oops, that doesn't make sense. $1,020. So I had to do the interest, add it on, and get the final answer. We want to do the shortcut formula, which is when the 4% growth, for example, is 1.04. So it's 104%. So we have 102%. We want to take what was it? Y equals, we're taking 1,000 and we're multiplying by 1.02. So that's kind of the big idea. When it's a depreciation, you say what you have left. And when you're going up, you're adding your interest rate to the number 1 for 102%. Because you don't want to have to do this 10 times. Add $20 the first year, then do 0.02 times 10, 20, add that on, then do 0.02 times that and add that on 10 times. You want to be able to quickly take $1,000 times 1.02 to the 10th power, and that gives you interest on your interest every single year. So can you calculate what you would put? 1.02 to the 10th? How much do I have after 10 years? 1 to 1899. I want to prove to you that compound interest is better than simple interest. Simple interest would be getting the same amount, $20 every year for the first 10 years. What is 10 times $20? 10 years times $20 would be how much money? 10 times 20? 200? So if I did simple interest, meaning every year I just get $20 instead of compounding interest on interest, I would have $200 extra. I have $218.99 extra. So being compounded every year was better than simple interest. Okay, that's on this page today, and then we're just going to change gears and talk a little bit about inverse functions. Population growth. I want you to set this one up kind of the same way. Amy's working in a biolab to create bacteria. There's 4 colonies originally, and they triple each day. It doesn't say 3%, it says they triple. That's the same as doubling, tripling, halving. That's the base right there. Find the number of colonies after 1 day if they triple. Write an exponential function and how many days until there's 2 colonies present. See if you can do number 5. And before we put it up, you're going to try to share your answer with someone next to you. Wrap that one up. Let's see. We start with 4 and they triple. All I have to do is 4 times 3 is 12 colonies, right? Okay. Exponential function. Y equals, I'm starting with 4 and I'm multiplying by 3 to the x. In looking at your papers, you be the judge. Is this the same as that? So just be careful. Some of you just write fast and whatever. You understand what you're writing, but this is a linear function and this is an exponential function. This says take 4 times 3 to get 12. 12x is the slope of your y. This one says start with 4 and multiply it by 3 to the x power. exponential. And then when you plugged it in, some of you actually got really specific in your table. You knew that it was between 3 and 4 days. So I would say by 4 days, right? 3 days is not enough. 4 times 3 to the third was only 108. 4 times 3 to the fourth is 324. So some of you, what did you get, like 3.5, 3.4? Some of you got really close to the nearest of the day. So that was good. Okay, so we're going to put that page away for just a day. We want to do a little bit more practice. The one thing that I skipped, wait, where's our notes on inverses? I just want to introduce you with the resource page on inverse functions. Anyone see where that is? I just wanted to look at our resource page, and tomorrow we're going to do some quiz review and practice, and I'm failing at finding it, though. Yes, inverse functions. I just wanted to look at the front page of 4.12. What is an inverse? An inverse function. You guys probably already know a lot about inverse functions, even though you've maybe never used the term before. Okay, 4.12. 4.12. We're just going to do the resource page, and then people who might still need to look at homework 4.5 or 4.6 can take a few minutes to look at that. Because I've burnt you out today on some note stuff. There was. We did it yesterday. It was at the bottom of 4.10. At least she's noticing. Good. Okay, so an inverse function. I'm going to actually just write something. You don't have to write this down. If I had 4 plus x equals 11, I want to solve for x. What can I do to both sides? Okay, subtracting 4 is an inverse function. So addition and subtraction is one pair of inverse functions that undo each other. Give me another pair of functions you know are inverses. Multiplication and division. So if I take 2 divided by x and get 8 or something, what would I do first? Both sides, I would multiply by x to get x out of the denominator. Now I have 2 equals 8x, and then I would divide by 8, right? So multiplication and division are another pair of inverse functions. Can you give me one more from last unit? We used the last unit, so quadratic functions. What's another set of inverse functions we've used this year? If I have x squared equals 16, how do I figure out what x is using inverse functions? Come on, you know how to solve this problem. Solve this. Take the both sides. Take the square root of both sides, and I would get 4 or negative 4, right? So x squared and the square root of x, another pair of inverse functions. And so I talked about if I have 2 to the x equals 11, and I want to know how many days my bacteria can double until I hit 11 million colonies or something, I don't have any way to solve that right now. I know that it's between 3 and 4 days, but if I wanted an exact day, I need an operation. I can't divide by 2 or subtract 2. So I'm going to take the log of this function. That's what's coming after vacation week. So I'm trying to figure out how to solve this. Before I can undo both sides, I have to understand what an inverse function even is. So what is an inverse function? Just the result of exchanging x and y, believe it or not. That'll undo a function. An inverse function is to undo the original. Here are the facts. You don't have to memorize a lot of this. It's just a lot of words. I'll just read it quickly. A comma b will become b comma a because you're just switching x and y. This is more of an algebraic advanced or pre-calculus concept. When you put one function into the other, guess what? It undoes itself. So if I put x squared under a square root, they undo each other and I just get x. Or if I put x plus 3 inside a function that says to subtract 3, x plus 3 minus 3 is just x. They undo each other. So it's just they're undoing each other. Don't get caught up in that algebra. If x and y are exchanging, guess what? domain and range, they'll also flip-flop. And our goal today is just let's find inverse 3 different ways. So that's just the idea on the resource page is exploring inverses in order to answer this question after vacation week with logs. So our first and easiest way is I give you a set of points and you just have to flip-flop them because all you're doing is switching x and y. So 7, 8, that just becomes 8, 7. And 0, -2 becomes -2, 0. And 2, 2, well, that would just stay 2. And if I want to do this graphically, if I could get some points, I could just flip-flop the points. So after I graph the line y equals 2x plus 4, can someone review that for me from linear? This is something we've learned this year. What's my y-intercept for this graph? Did someone say 4? 1, 2, 3, 4. I'm going to put a dot right there. All right, what's the slope of this line? This is a good review from our first unit. 2 over 1. So you can kind of go up 2 over 1 and then you're off your paper. And let's go a couple in the other direction, like down 2 over 1. So there'd be kind of a point up here, but then down 2 over 1. I'm just going to do a couple dots. I'll show you why I'm doing the dots, but if you want to connect them, you guys need a ruler for this one line, or I think you can do it. That's my original function. Can someone tell me the domain and range of that original function? That's what f of x means, original function. You see this little f -1? That's called the inverse. Oh, this is what I hate in math. Ready? What did we just learn that this is? 2 to the negative first means what? A fraction 1/2. Well, guess what? Then someone went and copied that notation for inverses, and it does not mean what this means. So it's like I just told you that this means reciprocal. Flip it over. This notation means inverse function. Does x plus 3 and x minus 3 mean reciprocal? So that is an inverse function using that notation. That's a reciprocal using that notation. The inverse function does not take 1 over x plus 3. It's not taking the reciprocal of the function. So I think they should have come up, I would protest and say you should have come up with different notation so that it wasn't confusing. But we're just calling it inverse. So what's the domain and range of a linear function? Yes, all real numbers for both. Does that ring a bell? So we're going to try to figure out what is the inverse going to look like. So I want to make this little table. For our original function, let's pick 3 points, maybe these 3 right here. Let's see, this is -2, 0. This is -1, 2. And this is 0, 4. What did it say that I could do to find my inverse? What did I do up top, my first strategy? So far, I've just built this black line original function. Maybe I'll do a different color. Let's do it in blue. How do I find an inverse? What was my strategy in step 1 up top? Just flip points. 0, -2, 2, -1. The negative stays negative, positive stays positive. You're reversing x and y. You're going to plot those points. If you don't have a different color, maybe use little x's or something. Like 0, -, I'll put x. 2, -1, I'll put a little x. 4, 0, I'll put a little x. So my blue x's are my inverse function of that line. And someone's going to come up with the equation for me, because you can figure out your slope and y-intercept of those blue x's. So I'll give you like 20 more seconds, and you're going to tell me what my function is, that blue line. Who thinks they know it? Right? You're just writing it kind of like we did 2x plus 4. What would this equation be for the blue x's? This is a great review of Unit 1. Who's going to tell me the blue x's? Y equals my y-intercept. You guys are just tired, right? Oh, what's the slope? I should do slope first. Close. 1 over 2. I have 1 over 2x, and then you already told me my y-intercept was -2. Do you think some of you remember that? You're just not saying it out loud. Does it make sense that this is this? I really hope. I really don't want to go back to linear again. What's the domain and range of that linear function? Still all real numbers. So this is just giving you like a flavor of what is an inverse. So it's this weird thing. I just switch x and y. I can switch x and y graphically. And our third strategy, the last one for today, is I'm going to switch x and y inside an equation now. This is going to help us figure out how to solve this when we get back from vacation. Kind of our last little piece of skills here. So if you want to switch x and y, I don't see a y in this equation. Where is there a y in this equation? Can I just write this as y equals, yes, x plus 4? This is the same thing we just did. We're going to see if we get the same answer. If I can switch x and y, would you agree that that's all that that means? I literally just switched x and y, but I did not switch anything else in the equation. So do you agree I switched x and y? I want you to solve this for y equals. How would I get y by itself? What would be your first algebraic step to get y by itself? Before you divide by 2, can we move so we don't make any mistakes? Let's subtract this 4 first. Are these big terms, x and -4? No. So x minus 4 separately equals 2y. Now I will happily divide by 2. Divide this whole thing by 2. Divide this whole thing by 2. Did I get the same answer? So I get y equals x minus 4 divided by 2. That does not look the same to me, or is it? So I divided by 2, and I got this as an answer. Did I get the same answer that I got up above? Can you divide each of these by 2? So would you get 1/2 x when you divide x by 2? And would you get -2 when you divide -4 by 2? Get the same answer? So 3 ways: switch points, graph it, or write the equation with x and y separately. So that's kind of either like a bonus, or maybe there'll be one question, find an inverse any way you can on Friday's quiz. And we're going to spend a lot of time on inverse stuff after vacation as well.